Hi everyone. In this video segment, I'm going to go ahead and show you how to plot data in a Word document. Sometimes it's easier to do this in an Excel spreadsheet, but you can actually use the same features in Excel in the Word document. I'm going to show you how to do that. So the first thing you want to do is you want to click on Insert. And then what you're going to do is you're going to insert chart. Okay, now this gives you all of the options that you have when you open up an Excel spreadsheet. So if you were going to do this in Excel, you would have the same values. For us, most of the time, you're going to be doing a scatter plot. So you click on scatter plot and hit OK. Now what's going to happen is it's going to come up with a chart automatically, and it's going to give you your data table right here. So what I'm going to do is I'm going to just make up some values. For the x-axis, we're going to make that time in seconds. I just like to have that there because if somebody's grading this, like me, I'm going to actually open this up and see what the data looks like. So let's just say that we get our data off of the calculator or off of whatever we're doing, okay? And now what we're going to do is let's just say that we've collected velocity measurements. We're going to assume a direction of east for this. Okay, so now I'm going to enter data from my experiment. Let's make that. I'm just making up numbers, by the way. So I'm not really sure what this is going to look like. Probably not going to look very good. Oh, okay. So there's my data. Actually, I'll be honest, this looks like two different motions. Right here, it looks like it's a linear motion. And then here, it looks like I've either changed my speed or I'm accelerating. This could be linear. Actually, it does look linear there and linear here. We're just going to ignore that and just say, okay, well, we're just going to try to do a linear fit for this data. Okay, so once you have your data, you're done this. Now what we're going to do is we're going to go ahead and do a line of best fit, and I'm going to show you how to do that. Over here, you're going to see a thing that says Add Chart Element. Click on that and go to Trend Line. And then what you're going to do is more trend line options. You could click on linear or whatever fit you want to put in it, but that's not really going to work for us. Okay, notice here something. I'm going to show you this. See how you have data points above, below, and above the line? This tells me right away that this is not linear, that this is actually quadratic. Because if I have it above, below, and above, then I actually have a parabola and not a straight line. So let's go ahead and change this to a polynomial fit order 2. And now what I'm going to do is I'm going to go down here and I'm going to go ahead and set the intercept to be 0. Because if I'm traveling with a time 0, I should have velocity 0. Maybe, maybe not, but we're going to make it that way. Now I'm going to put my equation on my chart, and I just click this right here. Okay, and you can move this up. Okay, now once you're done that, there's your equation. But we need to fix this. First of all, if you select all of the text, I just did that with a Control A, you can change the size of the text so I can see it, which would be nice. Actually, didn't do it. Let's do this. There we go. Okay, so now I can see it, and now I'm going to change the y to what I plotted on the vertical axis, which was my velocity. I'm going to bold that since I am unable to put a vector sign on it. What did I plot on the horizontal? That was time, so I'm going to replace all of the x's with t's. Now we do need units here, so the units here should be meters per second squared. Oops. Oops, let's do this. And we're going to put a squared 2 there. And let's see, that should be squared. There we go. And then we're going to put our units in here. And this will be meters per second. Wait a minute. This is going to be meters per second. Let me figure this out. Meters per second squared. So this is going to be meters per second cubed. And this is going to be meters per second squared. Now you may be saying, what? What did you do? How did you get that? We take the units of the units of y, which in this case are meters per second, divided by the units of x, which is seconds, but it's seconds squared. So it's meters per second divided by seconds squared, which ends up giving us meters per second cubed. Here we ended up with meters per second divided by seconds, which gives me meters per second squared. Okay, so this is meters per second cubed is the rate of change of the acceleration. So this just tells us that the acceleration is actually changing, which we're not going to really go into. We don't really talk about those problems in this course. But again, this is just an example of graphing, not an example of how to interpret the graph. Although looking at the units can tell you that. Okay, so that's it. You plot the data by clicking Insert. You go to Chart. You pick your scatter plot. Once you have your scatter plot, you enter your data into the table. Okay. This shows you all the elements you can add. Okay. Then you go into, once you click on the chart, you go over to, let's see, Design. You're going to click on Add Chart Element. You're going to go to Trend Line, and that's when you can add the more trend options, and that's when you can add up your, or change your plot and change how you do your line of best fit. Okay, and then once you have your equation up here, you change the variables, you add your units, and voila, you're done. And now you have your graph of your data in your Word document for your lab. Okay, I hope this was helpful. If not, you can keep watching it over and over again, or watch it while you're doing it yourself. And that way it can help you to prep your graphs in your labs.